Hello students, in the previous lecture, lecture number 3, we have started the pin diagram of 8051 microcontroller, or we have studied the pin diagram of microcontroller. We have also seen the physical device of 8051 microcontroller. Today we are going to start the architecture of 8051 microcontroller. Okay, so to understand the architecture, we have to go through the some basic fundamentals of the computers. So, any computer system which is fabricated with the help of several devices. It contains mainly the central processing unit, okay, then RAM, ROM, input output ports, timers and serial ports. Okay, so when we see the motherboard of computer, then it contains a separate particular chips for every devices. Okay, so you can say that many chips on the motherboard. So when you see the computer system, then central processing unit or CPU is one chip, like 8085 we have already studied. Then all other separate block requires a different chips. Okay, so these all peripheral chips are connected with the help of data bus, address bus and control bus. Okay, so these all different function ICs, RAM memory, ROM, IO port, timers and serial port, or anything additionally we can say the chips which is required to drive the motherboard is connected through data bus, address bus and control bus to the CPU. Okay, so when we want to make the computer, then we require all these things on a single board. Okay, now let us discuss what is inside the microcontroller. So the concept is something similar, but everything inside a single chip. Okay, so you can say that microcontroller contains CPU, RAM, ROM, IO port, timer, serial port, everything which is required to make a computer is available in a single chip. Okay, so these are the list of the components which is basic requirement to form a computer like system, or any computer requires this is the basic things. Okay, so this is the basic requirement of any computer system. But the term microcontroller contains everything on chip, where in case of microprocessor everything is on board. So are you clear about that? Everything on board and everything on chip. Okay, so microcontroller is everything on chip. Okay, so these all the elements are available in a single package, single IC. That's why we call it a single chip computer. Okay, so microcontroller did not require any other external components to connect with them to work as a computer. Okay, now this is a simplified block diagram of 8051 microcontroller. Please be careful, this is the block diagram, not architecture. Okay, so this is the block diagram. You can generally see the variety of blocks of microcontroller 8051 which is available inside the chip. Okay, so we have discussed that it contains the CPU. Okay, along with the CPU we need to connect the oscillator circuit or the clock generation circuit. This clock will given to CPU. CPU will drive this particular uh, uh, operations with the help of clock frequency. Okay, it contains an interrupt control block. It contains a 128 bytes of on-chip RAM, 4 gigabytes of on-chip ROM, two timers, timer 0 and timer 1, and four IO ports. Okay, four IO ports are P0, P1, P2, and P3, and serial communication control block, which is transmit and receive the data through external serial devices. These all the peripherals are connected with the CPU using buses. This diagram shows, this line shows the bus, which contains the address bus, data bus, and control bus. Okay, we have to discuss everything in detail in the architecture figure. Okay, so we will study everything in the diagram of architecture of 8051 microcontroller. Briefly, you have already seen the features of 8051 microcontroller. So you can see that there are three variants available in 80 series family of microcontroller: 8051, 8052, 8031. First invented was the 8031. So you can see that there is on-chip program space or on-chip ROM or program memory, which is 0K. That means it does not contain on-chip program memory or code memory, or we can say ROM. Okay, right now it is available in a format of flash memory. Okay, so this is a ROM-less version 8031. 8051 contains the 4K of on-chip program space, whereas in 8052 series of family, it is double up 8K of on-chip ROM. In case of RAM, you can see that there is a 128 bytes of RAM in 8031. Similar RAM available in 8051. But in case of 8052, the RAM size is double. Okay, 256 bytes. You can discuss the timer. You can see the timers available on board, or sorry, on chip, which is 2. In case of 8051, it is 2, and in case of 8052, it is 3. So IO pins are same for all versions because the package is looks similar of 40 pin. Okay, so 32 IO lines are there. One serial port available. Okay, and interrupt sources. That means the interrupt available on chip, that is 6 in 8031, 6 in 8051, and 8 in 8052. The number of interrupts are available and its description we have to discuss during the separate video lecture regarding interrupts. Okay. Now, let us move towards the actual architecture diagram. So this one is the actual architecture of 8051 microcontroller. We have to study each and every block in detail of the architecture. Okay, so now let us start from this unit. This is the ALU, arithmetic and logical unit. Okay, so every arithmetic and logical operations in this chip will be handled by ALU, that is performed by arithmetic and logical unit. Okay, as we are knowing, as you have studied the microprocessor, that to process the data inside the processor or controller or ALU, we need some registers. Okay, in case of 8085, you have seen that B, C, D, E, H, L registers are there inside the chip, where we have to store some data, and after storing we can process on it. Similar way, the two registers A stands for accumulator and B register are directly the part of accumulator. Okay, so these all registers are of 8 bit. Okay, because our 8051 microcontroller is of 8 bit. One more register which is directly connected with ALU, that is program status word. Okay, so PSU stands for program status word. We can relate this particular register with the flag register of 8085, that you have studied the flag bits and flag registers in the 8085 microprocessor. Similar way, we can see different types of flags inside the program status word. Okay, we have to study separate bits function of this particular registers. Okay, there are carry flag, auxiliary carry flag, sign flag, okay, bank selection bits. So we have to discuss this in detail. Now you can see that there are 4 ports. Okay, IO ports, we have a 32 IO bits or IO pins available in 8051 microcontroller. So this is divided into 4 group of 8 pins, that is port 0, port 1, port 2 and port 3. Okay, so this port 0 can be work as a IO pin, okay, as well as it can work as a multiplex address and data bus AD0 to AD7 for external memory interfacing. When we want to connect any additional or external memory with the microcontroller, this port will be occupied for the external memory connection. This is a port 1. It is a block which contains a handling of input and output data uh, with the microcontroller. Okay. Backside of this, there is a latch or a D flip-flop connected with each pin. So it can hold the data inside the flip-flop. So every bit or every pin contains a 1D flip-flop which is handling the input and output operation of the particular pin. You can see port 1. So port 1 is again a 8 pin containing 8 IO lines which is connected with the latch block. Okay, and this port does not contain any of the multifunction like port 0. Port 0 can work as a IO line and it can work as a address and data line. Similar way, port 1 cannot work with the multifunctions, means it having only and only one function, which is to input and output the data through this port. As we can see in the port 2. So port 2 is having again a higher order address bus and IO lines. That means this 8 pin can work as a IO line, as well as when we need it, it can work as a A8 to A15 higher order address bus, because we need 16 address bus and 8 data bus. Why? Because this architecture having facility that we can connect a 64K of total ROM. Okay, so to access this 64K of memory, we require 2 raised to 16 address line. That is nothing but the 64K of memory. So to access the 64K of memory, we need 16 address lines. That's why this 8 address line will come from the port 0 and another 8 address line will come from the port 2. Okay, and as we all are knowing that this processor is of 8-bit processor. Okay, so at a time this controller requires to carry on 8-bit data. So all registers we are going to discuss, we have seen A register, B register, PSW are of 8 bits. Okay, and processing capability of this ALU unit is 8-bit. Okay, means it can process simultaneously on 8-bit data. Okay, so Now we move, let us discuss this one is the 8-bit data bus. So you can see this is a data bus. This is a data bus. So data bus is connected through A register, B register, and this data bus going ahead, and it is connected with the PSW. Okay, so this is the 8-bit data bus. This goes to the internal ROM where we can carry the data. So data bus is connected with the ROM, data bus is connected with the RAM. Okay, again you can see the ports containing or connected with the data bus. So port is connected with the edge of the data bus. Okay, and this is also connected with the RAM. Okay, so here you can see that this is a special function register RAM. So now we have to study in detail with the memory map. What do you mean by memory map? So the internal memory available with the microcontroller is of two types, RAM and ROM. Okay, so we have RAM of 128 bytes. Okay, now the RAM is divided into three areas. Okay, one area of 32 byte, another area of 20 byte, and third area is of 76 bytes. Okay, now let us understand why it is divided into three area. So this is a 32 bytes. Okay, so it is again divided into four part, 1 2 3 and 4, and each part contain 8 bytes. Okay, so these 8 bytes are known as a register bank. As you can see, this is the 4 banks. Okay, so this 4 bank having the name bank 0, bank 1, bank 2 and bank 3. Okay, each bank contains the 8 bytes. Okay, so in a register bank 1, it occupies 8 bytes, and each register having the name R0 to R1, R2, R3 and R up to R7. Okay, so this is the bank 0. Similar way we have a bank 1 like this, which is again of 8 byte, and it also contains the 8 registers or 8 byte of memory like R0 to R7. Okay, similar way the bank 2, which is again 8 byte, and bank 3, which is again 8 byte. Each bank having 8 byte of memory and which is named by R0 to R7. Okay, so this way we have divided a bank registers of 32 bit and 4 banks. Okay, so this is a 32 bit 32 byte of memory which is of okay, so 32 bytes are memory 32 bytes of memory are allotted to the bank registers. Now the next area is of 20 byte, which is called the bit addressable RAM, where we can access a particular byte of memory by byte address, okay, and it is again separated by 8 bit. So in this area, the memory which is available, we can access a particular single byte of the single bit of the memory. Okay, so this area contains a bit addressable as well as byte addressable registers. So in this way we have a bytes, and inside the byte we have a bits. So we can individually write and read a particular bit of the memory. Okay, so this area having only this area having this facility that this is a bit and byte addressable. Okay, so this area is shown in the architecture uh, at this place. Okay, so remaining part which is of general purpose RAM of 76 bytes. Okay, so this is the general purpose area where we can store any of the temporary data during execution, okay, in this 76 bytes of GP RAM. Okay, so if we start writing the address of this 128 byte of RAM, then we have to write the address with the help of 8 bit. This is 00H to 7FH. So it is the last address of RAM. This is a 128 bytes. Okay. So if we want to access a byte address, then we can start from 00H to 7FH. Okay. Last register available in RAM having the address 7FH. Okay. So this is a common address. Any of the byte can be addressed or accessed by their address, which is starting from 00H to 7FH. Okay, so this is the memory map of the RAM. Okay, and this is a inbuilt RAM. But one interesting thing that we have to study about RAM is that we in this specification we have seen that the memory available on chip, which is 128 bytes, but in a microcontroller there is total 256 bytes of RAM. 256 bytes of RAM, but we can only access 128 bytes of RAM, but remaining 128 byte of RAM we cannot use directly in our program, but in this place there is a SFR, which is the important part of the microcontroller, which is designed in this RAM area. Okay, so this part is called the lower 128 bytes of RAM, which is user accessible, and this is called the upper 128 byte, which is directly not accessible by the user. But question arises that then what is the need of this 128 bytes? So to drive the microcontroller or to use efficiently the microcontroller, we have a this block. This is called the special function registers. This is called the special function registers. Okay, so the special function registers are designed or that space of register is given in this particular upper 128 byte of RAM. Okay, so in upper 128 byte there is a special function registers which is used to configure the microcontroller is going to be used or is inside the special or upper 128 byte of RAM. Okay, so I think you are right now clear that what is about the RAM. So let us we can recap that total 128 byte of RAM which is available in the 8051 microcontroller, but the hidden we cannot access another 128 byte of memory. So total memory is 256. You have to remember this, but 128 byte we can only use, and this is again divided into three portions. One portion of 32 byte, another portion is 20 byte, and third portion is 76 bytes. So first 32 byte is of bank registers. Okay, that is divided into again four part: bank 0, bank 1, bank 2 and bank 3. Each bank contains the 8 bytes. Okay, so each bank contains the 8 bytes. So this way this 32 bytes of memory is available. The another option which is bit addressable RAM. So this bit addressable RAM having a 20 bytes of memory, and this 20 byte can be accessed by byte address and bit address. Okay, so this is a second part. Third part is general purpose RAM. Okay, which is not shown here in the diagram, but remaining RAM is called the general purpose RAM, where you can store your temporary data for processing. Okay, so this way the lower 128 byte is configured. But what about the remaining 128 byte of RAM, which is upper part of RAM, which is not accessible by directly by the programmer? Okay, so this 128 byte is used to design or to provide the space for this special function registers. So remember, this name is called the special function registers. Okay, so the special function register having a dedicated task or dedicated work in the microcontroller. For example, if you want to use the timers inside the microcontroller, then how you can start the timer, how you can stop the timer. So that command or that control bits are available in such type of special function registers. Okay, suppose if you want to control the direction of port, then what you can do, that how you can define this port can work as a input port, this port can work as a output port, or this pin can work as a input or output. Okay, so the commanding registers, or you can say controlling registers, we are giving its name. This name is called the special function registers, and these registers need some space of memory. Okay, so these particular registers are available in the RAM, which is called the upper 128 bytes. Okay, so now clear about the RAM. Okay, and we have a 4K of ROM inside the microcontroller, which is this block. Okay, so 4K of ROM is simply having such type of block having starting address 000 0 to F, F, F. Okay, this is a memory where we can store our code. Okay, so now you have to understand one thing, that to execute any computer system, we need two types of memory. One is ROM and another is RAM. Similar way we can relate this with our computer. In our computer we need a hard disk, also we need a RAM. Okay, so what is the main task of hard disk? When we install any program or application, then it will be stored in a C drive or in a hard disk. But when we start this application, the important processing data will come into the RAM, and my CPU will connected with RAM. So when CPU needs to store some temporary data, or they needs to store some temporary variables, then they will use the RAM. Its name suggests that it is a random access memory. So CPU, and also it is faster. Okay, so CPU, when we start executing our program which is available in a RAM or application or anything or code, when it starts executing, it needs some RAM to execute. Okay, can you imagine your computer without RAM? It having hard disk, but it does not having the RAM. So will it start? The answer is no, it will not start, because CPU always need some RAM memory to execute. Okay, so CPU needs some temporary data to store. They need to need some database or some important data to be kept ready in RAM. Then and then your application or code will suitable to run. Okay, so you have to understand we need two memories. Now I think you will clear about the two types of memories we require and why it is required. Okay, so this is a RAM. Now important thing, you can see that we have a 16 bit of address bus. Okay, and data bus is of 8 bit. Why it is such that? So in the previous discussion we have talked that this is a 8 bit microcontroller. So at a time they need to carry 8 bit of data. But why address bus is of 16 bit? So I have told you that it can maximum connect, you can maximum connect 64K of memory with this microcontroller. But we have only 4K of memory which is available inside the microcontroller. So you can remaining 60K of memory you can connect additionally or outside the microcontroller. Okay, this is a memory. So to connect this additional 60K memory with this microcontroller, we need to connect this two port with the microcontroller. Why? Because port 0 containing AD0 to AD7 line, okay, which is multiplex address and data bus, where we have a D0 to D7 which is data bus, and A0 to A7 which is address bus. So this is a A0 to A7, and port 2 is working as a A8 to A15 higher order address bus. So combination of these two port will give a two separate buses, which is when we decode it, it is nothing but the D0 to D7 and A0 to A15. Okay, so this is of 16 bit. Why we need 16 bit? So I have told you that to access a different 64K location, the binary combination of bits we required is 16 bit. Okay, that you have studied in digital electronics, that if we have a two binary lines, then we can decode four different items with the help of two binary line, because only the possible way by using two binary bit we can write four combinations like 00, 01, 10 and 11. Okay, so to access 64K of memory, we need 16 bit of address line. That's why we have given here a 16 bit address bus. Now let us discuss this 16 bit address bus is connected with which blocks. So this is connected with the program counter. Starting from program counter, it is connected with data pointer. It goes ahead, it is obviously connected with the internal memory, but how we can connect this address bus with the external memory? So you can see that this line goes here, it is connected to latch, means port 2, and it goes to the, sorry, this line goes to the port 0. That means this address bus having only connection with the port 2 and port 0. You can see when I will remove this annotation, see, this is connected with the port 2 and port 0. Why? Because additional 60K of memory if we need, then we need to provide the access of external memory through address and data bus. So it is nothing but with the port 0 and port 2. Okay, so this address bus is connected in this way, but data bus is connected with another, through another way, through the data memory, through the RAM, through the every ports. Okay, this way, this line is connected to every port, means when we want to use this port as a bidirectional input output, then the data will go come or go through this port, will travel by this data bus to this data bus. Okay, similar way it can connect with the all internal peripherals, sorry, internal blocks. So this is a path of data bus. Okay, now you last point we have to discuss, which is a control unit. Okay, so control unit containing these portions, or it will handle this part. System timing, that means our microcontroller will work on the basis of clock frequency. Okay, so from where we can generate the clock. So these two particular pins is the crystal pin, as we have seen in the pin diagram. So these crystal pins are connected with the crystal. Okay, and this crystal will generate, helps to generate the clock frequency. Okay, in this block. So clock circuit is available inside this block, but which frequency we need to connect, that will be decided by the tank circuit, as we have discussed in the pin diagram. Okay, so tank circuit we are connecting, which is a combination of crystal and some PF. Okay, so you can see that. So inside this control block, they have a clock generator circuit. So this clock will be generated and it is distributed among all the internal blocks where they required. Okay, so it will also handle the system interrupts and timings. Okay, so we have a interrupts, which is 6 interrupts available in 8051 microcontroller. So how to handle the interrupt? As you are knowing that you have studied the micro processor, then what is interrupt, how the interrupt will work, how the interrupt will execute, what is interrupt service routine that you have used. When we start studying the interrupts of 8051, we will learn that how many interrupts are there, how to configure the interrupts, how to use the interrupt, how to write the ISR, everything we have to study. Okay, it is the another video lectures content. What is the another task? Data buffers and memory control. Okay, so this management block having also the task to manage the data buffers and memory of all microcontroller. Okay, so this is a important block. It is the commanding block or the control block or the control system of whole microcontroller. This will drive whole microcontroller. Okay, now you can see that all the memory related pins of microcontroller, which is three pins EA, ALE and PACN, as we have seen this function of these pins in the pin diagram. So this pin is connected with this control block. The reset option is also connected with this block. That means the resetting of the microcontroller will be handled by this control block. So this control block will also manage the power options. The power we have to give to this block, and this will be distributed to this particular whole microcontroller. Okay, so this is all about the control block. Then we have to discuss the two pointers available in a microcontroller. One is PC, that means program counter, and another is DPTR. So full form of DPTR is data pointer. Okay, so PC is what? Program counter. DPTR means data pointer. So we have a two types of memory, RAM and ROM. Okay, so how to point the RAM? So we can point RAM by using data pointer. Okay, but important thing is that the internal RAM is not using the pointer. Okay, this pointer is given here to access the outside memory which we connect additionally. Okay, external RAM. If we require to connect external RAM, then and then the use of this pointer will comes into the picture. Otherwise, you can use this DPTR as a general purpose data storage. One important thing that you have to remember that both the registers are 16-bit. 16-bit. Okay, one is the pointer of ROM. Now see that if we have a inbuilt ROM of 4K, then remaining 60K we can connect outside, from the outside if we need. Got it? Okay. Now to address or to connect this ROM with our microcontroller, we need address bus. Okay. So address bus is of 16-bit, and this 16-bit comes from the program counter. That's why our program counter is of 16-bit. So address bus we are connecting with this memory is of 16-bit. And one important thing, that combination of internal plus external memory should not exceed from 64K. Why? Because 4K of internal flash and 60K of external flash we can connect in case of ROM memory or program memory. Okay, so if we connect additional memory, then we can connect up to 60K. Okay, and the address generated for fetching the instructions will be from program counter. One line statement for the program counter is that program counter points the next instruction address to be executed. Okay, so program counter will point the address of next instruction which is going to be executed. So this is clear. So this address program counter knows that which next instruction should be execute in this program. So it will hold that after execution of current instruction, it will execute the next instruction from this address, and this instruction means our program which is written inside the ROM memory. Okay, so one by one instruction they will execute, and the address of instruction which came from the program counter. Okay, and DPTR, in case of DPTR, it is the pointer of external RAM. Okay, it is the pointer of external RAM. So if I draw the RAM, so it is again a 16-bit. Okay, DPTR is 16-bit, but it is divided into two registers, DPH and DPL. So DPH and DPL both are 8-bit. Okay, this is DPH and this is DPL. So it is combination of two register, and when we combine this to 8-bit, the register becomes DPTR. But it will only use when we want to access external RAM. Okay, so question arises that DPTR will not use for the internal RAM. The answer is no, it will not use for the internal RAM. Why? Because internal RAM is directly accessible by the data bus. Okay, so internal RAM need not required to point by the DPTR. It is directly accessible. So this pointer will allow to connect additional extra RAM if we required. So in case of RAM, we can connect, in case of 8051, we can connect whole 64K of RAM outside the microcontroller if we need. So in case of RAM, internal 128 byte of RAM that we can, it is already there in the chip, plus 64K of RAM outside the microcontroller. So in case of RAM, total memory access of RAM with 8051 is the summation of internal RAM plus external RAM of 64K. Okay, so total 128 plus 64K of RAM we can connect. In case of ROM, finally, we can connect summation of internal plus external is equal to 64K. Okay, so if we have an internal of 4K and we have an external, then external memory we can connect is 60K. So here in case of ROM, we have to sum up to 64K. We are not getting additional 64K connection because this program counter is used to access internal ROM as well as external ROM. So the total address is by 16-bit we can generate is nothing but the 250, 64K memory. We can maximum access by using 16-bit is of 64K. Because of we are uses this address to access the internal ROM, external memory we can connect is the remaining of this memory. That means you can say that 64K minus internal memory which is available on chip, and whatever the answer we are getting, that much amount of memory or ROM we can only connect with our microcontroller. Okay, the similar case will not happen in the case of RAM. Why? Because internal RAM of 128 byte will not require DPTR. Okay, so DPTR only works when we want to connect external RAM. Okay, so I think this fundamental is clear about the memory accessing of 8051 microcontroller. Okay, so that's it from the architecture side. Now we have to study in detail the functions of all the blocks, or we can say that timers, interrupts, serial communication. So after studying the architecture, right now we are not able to configure the timer. Okay, we are not able to configure the timer. So how these separate blocks or this internal hardware works, so that will require a separate video lecture, but I think this information is sufficient to understand overall architecture of the 8051 microcontroller. Okay, but internal hardware blocks we will study separately. At that time, we will study what is IE register, what is IP register. That means all the need of special function register, how we can configure it, uh, what is the function of each bits of this particular registers. Then and then we are further able to configure any hardware and program any of the hardware and which is available on chip, and we can efficiently run our microcontroller. Okay, I hope you will understand this lecture as an architecture of 8051 microcontroller, and you will try to read this particular all block related information from the book also. Thank you.